Hello, welcome to the Foreign Animal Disease Preparedness Part 1, Global Threats of African Swine Fever. In August of 2018, the first officially reported case of African swine fever was announced in mainland China. Over the next 9 to 12 months, the virus rapidly moved throughout China and started to affect other countries in Southeast Asia. So if you really look at the map here today, that whole Southeast Pacific area has now all had confirmed cases of African swine fever. So not only in China, in both North and South Korea, Vietnam, Cambodia, Philippines, Myanmar, the islands of Timor-Leste, and Indonesia as being the most recent country to confirm African swine fever. On the other side of the globe, African swine fever also continues to move throughout Europe, starting in the Eastern European bloc in 2008, infecting both domestic swine, which you see a picture there in red, as well as wild boars, pictured there in blue. It has began to move from east to west, with most recently being announced a couple of cases in wild boars in the western part of Poland. That gets to be very important because there are a lot of commercial pigs in Germany, and these cases are within about 20 kilometers of the border with Germany. There's a lot of pigs also in Denmark, a lot of sows in Denmark, and they send a lot of their wean pigs and feeder pigs down to Germany to finish out. Some things that the country of Denmark have been installing a fence to try to keep any potential pigs from getting up into the country, and Germany's attempting to do something similar with that, with the borders of Poland now, with this imminent threat. Officially, the Chinese government has confirmed about 163 cases with about 1.2 million pigs that have been culled due to African swine fever. Although unofficially, multiple confirmations report the incidence of this disease in China to be much, much higher. The cases are most likely in the thousands. There's been estimated to be about a 40 to 50% reduction in the Chinese breeding herd inventory. So the equivalent of that is probably at least the size of the U.S. breeding herd, which is about 6.2 million sows. That kind of reduction in the sow herd is also going to lead to a massive reduction in inventory of market pigs, 30 to 50% inventory. That's going to equal about 200 to 300 million market pigs lost. China produces somewhere between 600 to 700 million market pigs a year, so we're looking at losses that are approaching 300 million pigs due to the number of infected pigs and also reduced breeding numbers from all this culls of sows. As an equivalent basis, for comparison, the U.S. produces about 110 million market pigs a year. African swine fever virus itself is a very large and complex virus. It's very hardy and extremely stable in the environment, which is going to create a problem for situations where we want to clean it up. Because it's very large and it's relatively new in major pig-producing countries, there's not a lot we know or understand about the virus or what parts of the virus create immunity. A prospect for a protective vaccine doesn't appear to be very likely in the short term. This virus is very stable in the environment. Here you can see listed on the slide it can survive even in very basic high pH environment for a short period of time, but it can live for up to 15 weeks in putrefied or rotting blood at room temperature, 70 days out in blood at room temperature and wooden boards. It can survive 11 days of feces at room temperature, although that study has been done more out in a laboratory situation and probably is not equivalent to what a deep pit might look like. It will also survive out to 18 months in pig blood at refrigeration temperatures, 150 days in bone meat at 39 degrees Celsius, which is about 100 degrees Fahrenheit, and 140 days in salted and dried hams. African swine fever can infect both domestic and wild pigs. It can be transmitted from nose to nose directly from one pig to another, or indirectly through swill feeding or ingestion of contaminated pork products that have not been properly cooked. There are some biological vectors. Certain types of flies, particularly the biting flies or stable flies, can transmit the virus from infected pigs to healthy pigs by blood feeding activities. There is a certain species of soft tick, which can contain and persist that virus over a long period of time. That tick is not present at all in Iowa and only in the southwestern parts of the United States. Feces or anything that could be contaminated with blood of an infected animal, so boots, sort boards, vehicle tires, so on and so forth, could also transmit African swine fever. African swine fever does not appear to be transmitted from an aerosol standpoint, which is different from another virus such as foot and mouth disease. And essentially the thing to remember is the blood of infected animals has a very high concentration of virus. There are a lot of different strains of African swine fever. Unfortunately, the one that is currently circulating the globe causes really high morbidity, so lots of sick animals, and a really high mortality in pigs. It's important to note that it cannot be spread to humans, so there's no food safety or public health concern at all. In other words, people could eat infected pork products with African swine fever and nothing would happen to them. Currently, there are no vaccine or treatment options for African swine fever at all. So generally, the best course of action is to find it and eliminate the animals and clean up the environment. And most importantly, for any of the three foreign animal diseases that we're talking about here, African swine fever, classical swine fever, or foot and mouth disease, they're all trade restricting diseases. So an infection in our country would cause us to lose our exports. So what would pigs look like if you had pigs that were infected with African swine fever? Well, it's called African swine fever because the pigs that are infected tend to have a really high fever. So fevers of 105 to 108 degrees Fahrenheit are very common. Now, fortunately, there are not a lot of other viral or bacterial diseases that we have in swine that cause those type of fevers. So one message that we want to get out to pork producers is to make sure that we're temping sick pigs, and if we're getting temperatures in that 105 to 108 range, pork producers and caretakers need to contact their veterinarian immediately for further evaluation. Generally, early on in the infection, you may just see acute deaths of animals, or you may see animals that are just off feed, piling, huddling, may just look like other viral diseases that we have. Bloody diarrhea is also another thing that you may see in pigs that are infected with African swine fever. Now, with African swine fever, what happens is the blood, instead of staying in the vessels, it starts to leach out to other parts of the body. So some things you might see are hemorrhages in skin in areas that wouldn't normally see it. So in the ears, the nose, the tail, the hams, or in the lower extremities. In breeding herds, one of the first signs may just be an increase in abortions. And while not common early on, eventually sudden death of lots of pigs is what will happen over time period in a herd that's infected with African swine fever. So we mentioned earlier that any of these foreign animal diseases are trade restricting diseases. So why is that important? Dr. Dermot Hayes and his team of economists at Iowa State in 2011 were commissioned to do a study of what would be the economic impact of a foreign animal disease outbreak in the U.S. So in that model, they used foot and mouth disease because that was the clear and present danger at the time. But their team's analysis showed that the revenue loss by the different commodities would be an $8 billion loss for pork, primarily because the U.S. exports about 25% of the pigs that they produce. And on the day that the first case is announced, all those export markets would go away immediately. There'd also be a projected $3 billion hit for beef, $4 billion for corn, $1.5 billion for soybeans as well. So in this case, if we have a diagnosis of any of these three diseases, everybody in agriculture is truly going to lose. So what's being done to keep foreign animal diseases out of the United States? So border awareness is probably one of the two primary threats. So one of the threats would certainly be either contaminated travelers or travelers bringing contaminated pork products into the U.S. So what you see pictured here is Customs and Border Patrol increasing the amounts of surveillance using what's called the Beagle Brigade. So these animals are doing extra screening for passengers coming on flights from ASF infected countries in order to try to sniff out any agricultural products that are not supposed to be brought into the United States. So there are reports, many of the large airports, that confiscate anywhere from 200 to 400 pounds of illegal agricultural products daily from international travelers. Now in the U.S., any pork that's confiscated will not be tested, but in other countries, they have tested some of this confiscated pork products from Chinese travelers. And invariably, in almost all the cases, they are finding those to be positive for African swine fever. And in some cases, also positive for foot and mouth disease as well. Biosecurity for both international visitors and travelers are going to be very, very important. Current recommendations are 5 days down away from any swine once they have returned to the United States. Obviously, there's no imported meat allowed to be brought into the country. If you do have international visitors or travelers, providing those visitors with clothes and shoes at an off-site location and having them change and leave anything that they brought from their country of origin, a long ways away from the farm. Obviously, we talk about visitors here, but it's also important for companies who have employees that are traveling to some of these countries to adhere to these same guidelines. Probably the second biggest threat will be contamination of feed ingredients. In many cases, there are micronutrients that either the only one or two places in the world where those micronutrients are produced is in China. So that we wind up with the potential for contamination. In 2013, 2014, it's highly suspected that PED came to this country via contaminated feed ingredients. And the concern is, in some cases, with some of these micronutrients, they tend to be produced in human food grade manufacturing processes. So that part of it's safe. But in some cases, those micronutrients or antibiotics, for example, they add inert ingredients such as soybean hulls or corn cobs as filler in the bags that they're processed there. And you can see here, many producers will dry their grain on the roads, and you could have people hauling pigs infected with different viruses over those roads and potentially contaminating those ingredients that way. Looking at virus survival in ingredients, that was one of the outcomes from the PED outbreak. Dr. Scott D. and a team of scientists looked at the potential for these different viruses to survive a trip overseas, either transatlantic or transpacific, if feed ingredients were contaminated. So what they did is they took the different feed ingredients that are commonly brought into the country, and they contaminated them with various different viruses, African swine fever being one of those. And then they put those ingredients in an environmental chamber that mimicked a trip from Shanghai to a feed mill in Iowa, and then from somewhere in Europe to a feed mill in Iowa. And using historical time and relative humidity information on data loggers, fed that into the environmental chambers to simulate those trips. And then at the end of those, they took those feed ingredients out and they fed them to pigs, or they put them into cells to see if the viruses were still alive at the end of these simulated trips. What you see here is a table looking at some of these different viruses, some of them pig viruses, some of them are surrogates for potential pig viruses as well. We're going to focus here on African swine fever. So everything in red there, you can see were the ingredients that where the virus, in this case African swine fever, survived in that simulated trip across the ocean and could still infect pigs at the end of that 40 to 50 day transit time period. So you see ingredients such as soybean meal, soy oil cake, choline, so on and so forth, were ones that could harbor African swine fever and keep it alive over that time period. Some work that's been done on African swine fever with the group from Kansas State University down at the National Biosecurity Center in Manhattan, Kansas, they looked at how much virus could be in either feed or in water and still infect pigs. So it really was a titration study in the truest sense. What they found, unfortunately, is the infectious dose, so the amount of virus in either feed or water, tended to be very low, and water was much lower than feed. And because if you either have the well or water source infected or the feed infected, it's not just like it's a one-time exposure, because pigs will need to eat and drink multiple times during the day. So what they saw is the risk continued to increase over the multiple doses that they took. So really what we need to think about to prevent transmission of any of these foreign animal diseases into the U.S. swine herd is what sort of hurdles can we put into place to prevent potential pathogen transfer through the feed. So Dr. Cassie Jones at Kansas State University has put together this nice pictorial of that. So what are some of the things that producers can do in order to prevent that transmission? So one would be exclude high-risk ingredients. So if there's an ingredient that a producer gets from China and that can be procured from some other plant in a different location of the world where African swine fever isn't present, that would certainly be an option. Another thing, too, is to extend biosecurity practices from the farms and start to putting those into places at the mills. That's one of the things learned during the PED outbreak, was that the virus certainly can be transmitted just by people crossing footpaths and things like that. And a third option, or a third hurdle to put into place to prevent that, would be to utilize some sort of mitigation additive into the feed to reduce the risk of the virus continuing to survive if they were in contaminated ingredients. So feed delivery, because it happens so often and those feed delivery trucks tend to go to lots of different farms and aren't washed between every individual one, feed deliveries is going to be a high risk as well as the risk from contaminated ingredients. Really what Dr. Jones and others have really started to work on is looking at feed mill biosecurity. So taking and implementing some of the things that we've learned to do on the farm and putting them into the mill. So things such as footwear, making sure that there are lines of separation, people are changing footwear, there's no cross traffic between clean and dirty lines, and making sure that truck cabs and tires are clean, are things that feed mills can be focused on in order to reduce the risk of transmission of African swine fever. Really, any of those biosecurity measures would apply for any of the viruses that are already endemic here in the U.S. There is the potential to mitigate feed. There are some available options out there. So these are compounds that can be added to complete feed in order to potentially inactivate any viruses that would be in the feed. Now, none of those are labeled per se for African swine fever. They're generally labeled for salmonella control or as energy sources. So things such as organic acids or medium chain fatty acids or some blend thereof are options, things that can be added to the feed to potentially reduce the impact of any viruses, if there are any viruses that would be in feed products. These are some options listed here on the screen. There's a lot of work being done on them. Today, we don't know if any of them absolutely will kill African swine fever virus, but they've been shown to be effective against other viruses such as PRRS and Seneca virus and PED virus as well. And currently there's some research going on to see how effective they are against African swine fever.